Okay, one of the other things that we can do with logarithms is use something called a logarithmic scale. And that's a way of rating things, especially things that are really different in sizes, without using numbers that are really big in size. So an example of that is the Richter scale, or the moment magnitude scale that they use for measuring earthquakes. On the Richter scale, quakes are measured on a list of numbers that are pretty much from like 1 to 10. A Richter 2 earthquake is like a big truck driving by in front of your house. The windows rattle a bit and nothing else really happens. And at the top end, earthquakes in the 9 bring down the best buildings that humans can put up. All that gets compressed into a scale that goes pretty much from 1 to 10 when you use logarithms. And the way it works is like this. They have two formulae that govern this scale, and the first one says that the amplitude, meaning the seriousness or the destructiveness of an earthquake, is 10 to the power of the Richter difference. So this is what you do when you're comparing two earthquakes. If you have an earthquake that's a 7 and another earthquake that's an 8, the Richter difference is 1, right? They're only 1 apart on the Richter scale. 10 to the 1 tells you that the amplitude difference was 10 times. This earthquake, the 8, was actually 10 times worse. On a normal scale, you'd look at a 7 and 8 and you'd say, yeah, this 8 was higher, but not by a heck of a lot. On a logarithmic scale, one step like this actually means 10 times worse. If you go from 7 to 9, you go 10 times worse, 100 times worse. And 3 steps is 10, 100, 1,000 times worse. So the numbers pile up very quickly on a logarithmic scale. The flip side of this, if you write this in logarithmic form, is that the Richter difference between two earthquakes is the base 10 logarithm of the amplitude difference. So if an earthquake happens and then the following week another one happens and it's 500 times more severe, this formula says if you want to know the Richter difference, you do log 500. And that tells you, okay, an earthquake that was 500 times worse is 2.7 higher on the Richter scale. So the first one was a 4, the next one would be a 6.7, for example. Fair enough. We get to practice this a whole bunch more at the bottom of the page. So let's see what they have for us. An earthquake of magnitude 8 is how much worse than an earthquake of magnitude 7? Well, we have a formula that says the amplitude for an earthquake is 10 to the power of the Richter difference. So the Richter difference here is 1, and 10 to the 1 is 10 times. The 8 earthquake was 10 times worse than the 7 earthquake. 7 versus 3, now we have a Richter difference of 4. And so our amplitude for this would be 10 to the 4th power, which is 10,000. A 7 earthquake is 10,000 times higher in amplitude, or releases 10,000 times as much energy as a magnitude 3. How about 4 versus 6? What's our Richter difference there? If you said 2, you're mostly right. The best way to do this, if you're saying a 4 compared to a 6, is to say that the Richter difference is minus 2. This earthquake is 2 lower than the other one we're talking about. And 10 to the minus 2 comes out to 1/100th. So the 4 earthquake was wimpier. It was only 1/100th as energetic, or had 100th the amplitude of the Richter 6. 4.8 versus 6.8, kind of a trick question. The Richter difference here is minus 2 again. So again we find it's a 1/100th. The lower earthquake is only 100th as violent or destructive or whatever word you want to use. Okay, the 1960 earthquake in Chile, which you can find on the scale at the top of the page, was a 9.5 on the Richter scale, one of the worst we've ever measured. The 76 earthquake in Italy was a 6.5. And the 1983 in Colombia was a 5.5. So, Chile compared to Italy. 9.5 minus 6.5 means our Richter difference was 3. So this is 10 to the 3, or 1,000 times worse, the earthquake in Chile was. And Chile compared to Colombia, I'm sorry, I wrote that in the wrong spot. Here, 10 to the 3 is 1,000 compared to Italy. Compared to Colombia, 9.5 to 5.5 is a Richter difference of 4. So the Chile earthquake was 10 to the 4 times, or 10,000 times greater in amplitude. And finally, last one, we have the 66 earthquake in Turkey, which was a 6.9. And the 1933 in Japan was an 8.9. Once again, our Richter difference is -2. The Turkey earthquake was lower. So 10 to the -2 comes out to a number we've seen before, 100th. The 6.9 earthquake was 100th the amplitude of the 8.9 earthquake. So, amplitude is 10 to the power of the Richter number, and if we get to finding Richter numbers, the Richter number is going to be the base 10 logarithm of the amplitude difference. So amplitude difference will be like, they'll say this earthquake was 30 times worse or had an amplitude 500 times greater. That's your amplitude. Log it and you'll get the Richter difference.